The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
I might change the title later. We'll see what happens. Depends on how angry you get. I thought you were going to make a trip down to Dallas. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. How are you doing? What did you do this week? I'm not asking if you did anything because I got a shitty response last time, but what did you do today? What did you do this week?
This week I've just bounced around. Like all I've done today was VFDs, installing VFDs. Just mindless VFDs.
Did you program them and all that other stuff?
I got to that point. It was trying to get them in, and they were like 8 feet in the air, so it was a real fucking pain in the dick this time.
Whoa. 8 feet in the air?
Yeah, they had 8-foot leg extensions on them.
Why?
I don't know. They're on top of a parking deck too, so it wasn't like, I don't know. At one point I had my extension ladder out until somebody else got there with a ladder because I didn't have a ladder on my truck.
That seems kind of ridiculous.
Yeah, it's tall. Like my 24-foot extension ladder, not extended, was just making it over the top of the condenser.
That seems ridiculous.
Yeah, so I did that, and I'm going to go back and program tomorrow afternoon. I got them in bypass, and then I swear to God, every time I get a Danfoss drive, the cabinet's different. Every time.
What? Say it again?
The cabinet is different. Like some of them have 110-volt bypass setups. Some of them have the Danfoss bypass setup internally. Some of them have some random-ass programming for the bypass setup inside the drive. You never know what you're going to get.
Or you might be working on it for 2.5 weeks and still don't have the VFD working.
There's that. I will say this, though. I hate their electronic bypass boards.
Wait, what?
The electronic bypass boards they use for the
little green thing about yay big?
No. That's the bypass relay adapter kit. There's like another board that some of them it clips onto the drive. On the bigger drives, it's an extension of a drive. On the smaller drives, it's like a separate board with the fucking world's smallest terminal block. And I had one today, really got me. It was the first one I did. They had the stickers wrong on the terminal block.
What, for the relay? And
so they're labeled X59, X57, and X58. You would think it'd go 987. No, it doesn't. It skips it in the middle, so it's 978.
That's so cool.
They had the terminals labeled. They had the blocks of terminals labeled backwards. So I had hooked up to the wrong terminal all along with a diagram. I couldn't figure it out, and I was getting really angry. And then I looked at the other one, and I'm like, wait a second. I go, this one's opposite. Move the plugs around, and everything started working.
That's amazing.
Yeah, not good when somebody could just slap a sticker on there and it's the wrong one.
So wait, you've been doing VFDs all week?
No, just today and yesterday, and then what did I do the rest of the week? Oh, I started some cases and then missed a job walk and something else. I don't remember. Oh, I went and walked another CO2 store we were doing.
Yeah, what was that all about?
Massive rack. I think it's this customer's first CO2 store. So massive rack. Walked in and got looked at the rack and went, oh, this isn't wired right. So at least we caught a bunch of stuff before. We're like 2 months away from startup. So it all got caught before. So hopefully this will actually go good this time. So there's that.
I'll have that on the big jobs.
Yeah, it's a massive fucking rack. It's probably the biggest flash tank I've ever seen.
Yeah, you were saying it's taller than you?
It's over 7 feet.
Holy shit.
Yeah. Yeah. It's going to hold more gas than the rack.
Yeah, I do have to tell you, you showed me a picture, and that's a lot of, there's a lot of room to work on the rack.
You could put 2 more racks on there. Like literally, like there is room for a whole nother stack of like double stack of compressors.
Once again, what are you going to bitch about that though?
Yeah, you should have seen how we had to get it up there.
Oh, really?
We had to hire a company to bring it up.
Damn. You said it was how long? 53?
It's over 24 feet.
That seems like a lot.
They had to hire a rigging company to get it up there because the roof was already on and you couldn't use a lull. They had to bring it to the floor.
That seems really ridiculous.
And it's oblong, so like the one end of the rack is 3 times the weight of the other.
Nice. So what made you want to do what you want to do today? You want to do HPV Troubleshooting 101?
Yeah, because I keep getting random calls about this.
Okay. Are we doing icad?
We'll do them both because it all ties together.
Sure. Okay.
We'll start with
where you're going to start.
We'll start with the icad since it's the old method. So the Danfoss icad valve is going to be what you're going to see on most older racks. It is a magnetically driven valve with an actuator on top. So actually pretty nice, robust, solid thing. I have yet to see one fail. I've never seen an actuator fail. So they're pretty robust. Now, they are susceptible to moisture, so keep them from getting wet. On these actuators, at the top, you have a nice display, shows you how far it's open. And then you get a 0 to 10 volt signal, DC, that drives the actuator. It could also be 420 milliamps, I believe. I don't think anybody really uses it.
No, so I have a question though for you because this is something that I never understood and I meant to ask you. So each one of those valves, because it actually goes on to the driver goes on the valve itself.
Correct.
So those valves have a certain amount of steps, which is it essentially pulses that magnet to turn, correct?
Correct.
Oh, okay. I was just kind of confused by that.
Yeah, it pulses the magnet to turn. So it could still lose its steps. So it pulses the magnet to turn. So on that valve, it can either be 0 to 10 or 4 to 20 milliamps, depending on how you set it up. And it's all in that valve actuator. If you read the manual for the valve actuator, it's got like 10 settings. Super simple. Now, the only thing that's a pain is troubleshooting loss of signal issues or other issues, because if you lose your 0 to 10 volt signal, it's going to close. It is not a 10 to 0 volt signal. So if it loses its signal, it's going to be wide open. It's going to close. So we've had
you can't inverse the signal.
Correct. We've had issues with these where they've lost the 0 to 10, or they're short on the 0 to 10, or they're not getting the 0 to 10. I will say this. If you don't have like a mechanics tip like set for your fluke meter, where it make an extension on it where it's like looks like a needle almost, you're going to have a hard time troubleshooting this. What cheap ass meter is that?
It's one that I got for free. Shut up. But still what you're talking about.
So yeah, you need a real fine.
Such an asshole.
You need a real fine needle, basically, to get inside the M12 connector. So it has an M12 connector like you'd see on the Sporlan valve. It's that same connector on there, not the same exact to a T, but it's the same style connector. So what you're going to have to do is find the pinout for that on the Danfoss manual. It'll show you for that valve. It'll show you the top two pins are going to be your 0 to 10 or the vice versa, however it's set up. You're going to put your meter in there and you're going to measure it and see if you have 0 to 10 volts and make sure you have your 24 volts AC or DC, depending on how the valve's powered. So that is how you're going to have to troubleshoot it to pull it off. There's no real way to, unless you pull the valve apart, to get to your 0 to 10. Now on this valve, you also have a 0 to 10 volt or 4 to 20 milliamp return signal. So you're getting a return signal on how far this thing is open. So it gives you a feedback signal. Now there's a screen inside this valve and it does plug up and it is quite fine. So if you are having issues where the valve is 100% and you could hear it, if you go to take the power off the valve and power back up, it's going to run through its zeroing sequence. It's going to shut the valve 100% and try to overdrive it and try to bring it back to zero. If you hear it and it's moving and you put your hand there, you feel it moving and you're still getting really crappy flow through it, pump it down, pull it apart. You need to have a gasket kit for it because it's an O-ring. Now, I've pulled them in the past, and what happens is the O-ring gets, CO2 gets in the rubber of the O-ring, and it like pops out. So what you could do is take liquid CO2 and just soak it, the O-ring, and it'll shrink back. And it'll shrink back enough for you to get it back together, and 90% of the time it won't leak if you're in a pinch.
So I'm going to just add this to here real quick, just to solidify what you were talking about. Right here, here's all your terminals for this thing, right? So you have common alarm, Bron for the fully open, the digital output. You're talking about the analog in, so you can go 10 volts, 4 to 20 volts, and then 4 to 20 input, 4 to 20 output, and then basically 10 volt output. And so these are basically those terminals is what you were talking about right here. So if you flip those guys around, those pins are really itty bitty teeny tiny. So that's what he was talking when he was making fun of my meter leads.
So generally the wires for Danfoss are labeled also. Generally.
Oh, really?
On the plugs, yes. At least on their valves, they're pretty good about labeling the number on the wire. So if you look at the number on the pin, generally corresponds with the number on the wire. Cool. So if you may have to strip it back a little bit, but you could see
the shielding, right?
Yeah, the shielding you may have to strip back a little bit, and you could generally see it. So this valve, and then here's the valve tool to open it for you to go back. That is the magnetic tool for you to open it. It should be in the rack cabinet. To be honest, I've never had to use one because every time somebody says there's an issue with one of these valves, it's either missing the 0 to 10 volt signal, something happened to it, or it's plugged up.
That's one. Yeah, also, I didn't know
that they're all different.
Oh, they are?
Yes, that will not fit on every valve. Like, it'll only fit on that size valve. So if you have a different series size valve, like a 2-inch one, 1.5, they're all different.
Damn, I didn't know that. I also realized that the bottom portion here, the actual threaded portion, is actually for the valve. So the seat of this valve, one of my buddies actually had one where the seat was actually loose upon startup. So the valve was saying that it was at 100%. It was in fact at 100%, and I told him to pull it apart after he had the gasket or whatever, and he didn't. But needless to say, he did that, and the seat from startup was actually loose.
I've had that a lot on the CCM valves. I've had the seat be loose a lot in the CCM valves. So taking that nut apart is pretty tight. So Make sure all the pressure's out. But then, do you have a picture of the screen?
Maybe not, right? Yeah, I think so. Just give me a second. Just
So
keep talking.
there's 3 or 4 Allen screws on the top of that valve. They're metric, of course.
3, 1, 2, 3.
So there's 3 metric Allen screws there. Don't lose them. Take them all the way out. Put them in your pocket. And then when you go to take this thing off, there's O-rings underneath there. So you're going to have to wiggle it back and forth. Just wiggle back and forth, wiggle, and then it'll pop off finally. Once you get the head off, don't worry about it burning up or anything like that. There it is. So once you go to spin this thing out, that's a CCM valve, but same type of deal. So you have this screen here. That is pretty common.
This is the O-ring that he was talking about. If you don't have a replacement for this thing gets impregnated, which is funny because it's opposite of what usually a rubber does. But essentially what you can do is isn't it though? Rubber usually prevents being pregnant. This one, it gets impregnated. So anyway, what you can do is spray with a little bit of liquid CO2. And a lot of times you can get it to fit, but I fully agree with what Kevin said. Don't play a game of FAFO. Just get the rebuild kit. If you should have one on site for this valve. It is the main heart of this freaking system. So just have it.
Yeah, and I would say at least one time after startup or within a year runtime, it should be cleaned out. Generally, when you're looking at these valves, if you see them more than 60, 70% open,
yeah,
and your head pressure's not like super fucking low, driven down, that valve's plugging up.
I was talking to someone about this. So they actually have the other valve, the one that is not this one, the actual
CCMT.
The actual icad. And so he tried to recalibrate that one. The valve was saying the percentage at the top. So here, if you look at blah 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 here, it actually gives you a percentage at the top. This one actually shows that it's 44%. This guy's was showing 100%, and if he's this valve's at 100% in the end, the BGV's at 10%. I was like, then that valve is probably not working. I don't know. I tried to recalibrate it, still didn't work. So I think I told him that he needs a rebuild kit before he pulls that crap apart. It's on a store that rhymes with Maldi's.
Oh, I know all about this store.
Yeah. You do?
Yeah.
Anyway, go ahead.
Yeah. So that valve's at 100%. It's not opening. On the icad actuator, it gives you a percentage readout of what it should be. And then your feedback signal. So we have to convert that 4 to 20 milliamp feedback signal to, if you're using Copeland, it needs to be 0 to 5 because it can't take 0 to 10. So
do they have you put a resistor in there?
Correct.
Oh, okay.
It's a 500 ohm resistor.
Yeah, so 250. It's similar to what Danfoss does when they make their IRLDS actually talk to the Danfoss, where it tells you what stage or what system is actually has a leak, and then as well as what
that's witchcraft.
No, it's not.
It's witchcraft. No, so you gotta watch the resistance on there. So it's for 0 to 5, it's 250, I believe, correct? And then 0 to 10, it's 500, or it's either backwards. I always have to look it up.
I'm gonna have to look it up because I don't remember.
Yeah, because it's both those resistors will make as one of them makes a 0 to 5, one makes 2 to 10, and one makes it 0 to 5. That is how you convert it, and you have to be like a high-end resistor. Don't get like a crappy resistor.
Precision resistor. You want something that's right on the money.
You paid 3 times the amount of money for.
Yes, because essentially the value of it is precise. They make it like a 10% ohm resistor and 5%.
They're all made in the same factory. That just slap an extra sticker on there.
No, they don't. Stick. Anywho, so continue.
Okay, so making sure you got 24 volts DC at it and it's not shorting out. So make sure you have that on there, and make sure that if it has a battery backup, it's good. The majority of the issues I see with this is you get the valve lifting off the seat from moisture getting in there in the wintertime and it freezes.
Okay.
So we've seen that. The valve plugging up has been the number one issue. You get shit in the strainer. That has been the number one issue. If you see a high valve percentage, a lower than normal flash tank percentage, and high subcooling, you have a restriction. You're not letting enough gas through that valve, and it may not be 100. On smaller racks, if you see that valve open more than 60, something's up. Especially in the summertime, if you see it open a lot more, you're going to have something up. If in the wintertime, though, you may be open 60, 70%, especially if you're floating your head pressure down and you're not afraid to bring the head pressure down and let everything float down. And you may be open more because your head pressure is lower. The closer you get to flash tank pressure, the more the valve's going to be open.
Yeah, that makes sense. You're basically acting like a conventional commercial or chemical refrigeration system at that point, right? Because I've seen someone where they float it down as low as almost what the flash tank is.
Correct. And then if we go to what would be the CCMT valves, they're going to be a more dumbed down version of this. Not as fancy, but just as reliable.
No, it's fine. Before we skip off to that, did you see the new valves like this?
No.
They're Bluetooth.
Are they?
They're Bluetooth. Go ahead. Keep talking about what you're talking. I'll see if I can break it up.
That's cool for when certain OEMs mount them up to the top of the rack and you can't even see the screen and you got to program it off a mirror.
You're so angry.
Yeah, I was angry then. So Danfoss also makes a CCMT valve. This is a bipolar stepper motor. Just like a CDS valve would be. So it is a high pressure bipolar stepper motor. So the CCM and the CCMT are the two valves they have. The CCMT comes with the built-in pressure transducer. So it would have a Danfoss built-in high pressure transducer. So if you were using a Danfoss valve driver, it just plugs right in, easy peasy. Now, a CCM valve is the same one, it's just a different body without the pressure transducer tap. It's a bipolar stepper motor. It has a screen in it, just like the one that Brett showed in that picture. It has a very fine screen in it, and it will plug up, and it has an O-ring on there. Now, the biggest problem I see on startup of these is they're wired wrong, and it becomes a shit show. As Brett remembered from summertime when it was like iPro wiring versus CCM wiring, 2-valve controller versus CCM wiring, Danfoss controller versus CCM wiring, Corel versus CCM wiring. Every one of them is wired differently for the same valve.
The CCM?
Yes.
And then the other one here?
That's a CCMT.
Okay.
So the other one is not a CCM. The first one, that's a...
Today's episode is sponsored by the RefRush-Shield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Oh.
It may be a CCM. No, it's a CCM.
Yeah, it is. It is.
So that's a CCM valve, and the CCMT's got the tap on it. Now, you'll notice it has the M12 pigtail coming off of it, and we had a couple stores where they shipped out with the wrong pigtails. So if you're replacing like a Copeland CV valve with a CCMT valve, the pigtail the M12 connectors will meet up, but they are pinned out differently. So same with the Sporlan ones. You could use a Sporlan pigtail connector on there, but it is pinned out differently.
Gotcha. And we between you and your brother, Basically, we have that, which we
Yes.
created, which basically tells you all the different valves. The only one that I saw that wasn't on here is the CCMTL, as in light. It's a smaller
Never
valve.
seen one.
Man, the first time I saw one, I was out in Cali, and it has 210 steps.
Yeah, it was probably on something that like you're never really gonna, maybe like those small little single units.
They're using them more. No, it was on a rack. It was on a rack.
Yeah, the step chart has been between me and Dylan. This took forever. Dylan made the chart. I sat there for forever trying to figure all this out and go through. And this was trial by error. And I'll tell you this: like it wasn't the CCM, it was the CC or whatever the BGV valves are, the CMTs.
Okay, this one.
So too many fucking acronyms.
Right.
Those ones, if you overstep them the wrong way, they walk off the C clip.
Not good.
Or yeah, it's a CCM valve. Technically, it'll walk off the C clip. So you want to really watch that. And then same things. If you have high subcooling and you have higher than normal pressure and you have high valve percentage, more than likely you're backing up in the gas cooler. Now, if you there's other things that could cause this. You could have a higher than normal receiver pressure, and that valve is backing off to protect the receiver. You could have a receiver issue. I've seen multiple flash tank valves cause high pressure valve issues.
Yes, let me show you that real quick. If you have a low receiver pressure alarm, what's going to happen is, because that receiver pressure is so low, we want to get that receiver level back up, because if we don't get it back up, then essentially we're not going to have the differential to push out the liquid out to our medium temp cases. So if you have a low receiver alarm, what will typically happen is your BGV will start to close off and your HPV will actually start to open up to compensate, to try to get that pressure back up. And then same thing with this guy here. If we have a high receiver alarm, which is usually the cause of a lot of high pressure issues, essentially if your high receiver pressure is higher than what it needs to, I've typically seen these about 50 pounds off of whatever the relief is. Basically what will happen is the BGV will try to open up to relieve that pressure into the medium temp suction, and then the HPV will essentially try to close down. I've seen both where the BGV itself is broken, and then essentially it's stuck at a certain percentage, and I've seen guys replace the high pressure valve, they'll replace the controller thinking that it's an issue, and it all leads back to a broken either driver or a broken BGV.
Correct. I've seen multiple issues that happen. And I will say this, if you're using like a BGV and you have a 326A and a 326A dies, the BGVs get replaced. I will not put a 326A in that's shorted out without changing the BGV.
Yeah, didn't you really get a really important lesson with that thing?
I didn't. Somebody else did that was helping. But yeah, so every 326A that I've found that has been shorted out has been a bad flash gas valve, and it never shorts out right away. It's always when it hits a bad spot in the valve and shorts out.
Waits to warm up, like it's not shorted to the point where it's instantly shorted.
No, it was shorting to the point where it was hitting like 80-90% open, and once it got to like that 80-90% open, it was super loose, and it was hitting the stator was hitting the rotor.
Ooh, I'm wondering if you can high pot that bitch.
You don't need to high pot it. You take that. I took it off, and like when it was all the way out, you could flick the stem like back and forth like a ping pong paddle.
Fine, don't have to do that then.
But yeah, just about every time you end up with low receiver pressure issues, it's generally a BGV issue, not a HPV issue. So the HPV gets blamed more than the BGV when it's the BGV. And then same thing with cycling issues. So like Hill Phoenix likes to tie their shutdown signals into these like tiny little relays, and it kills the 326A or the iPro enable. Those relays take a shit all the time, and they do it intermittently.
You're talking about the solid state ones, yeah?
Yes. So those solid state relays, I've seen them intermittently take a shit and cause HPV issues because it's constantly throwing the iPro, the Danfoss 326A, and startup and shutdown, startup and shutdown. It's less worse with the iPro because you can graph it. The 326, you can't graph it. So you end up seeing the startup and shutdown signal nonstop on the 326, and it may be causing head pressure issues.
Who makes that one? I want to say it's like Omnicrom or something like that.
Yeah, I think it's Omron. I think it's Omron.
That's what it is. I looked up Omnicrom.
Omnicrom. That's another one. And then here's a huge issue that I see guys miss a lot on the 326As is they will have transducer issues because nobody's able to verify them really because they don't know how. So on that 326A, if you hold the buttons down and you read the manual, you can get to the U menus and that'll show you on there what the actual pressure is in bar, and you can compare it to whatever the EMS controller is to see what it is. Now, the only thing that sucks is we've had a few plug failures or transducer failures. Once the failure clears, it's gone off the 326. So if you have an intermittent transducer issue, which we had at a store, and it would randomly high head, it would high head for 30, 40 minutes straight, and enough where it would set the alarms off. They'd call a guy out. He'd get out there, and the rack would be running.
Lame.
And you go through it every time. Finally, we caught it, and it was dropping the signal out on the transducer for the high pressure valve. So it was slamming it shut. It was reading 0. So when it reads 0, the 326 was slamming it shut. But everyone knew there was a 326 alarm, but nobody knew what the 326 alarm was because after they got there, the alarm was cleared.
Gotcha. I'm sorry, I'm trying to get this. This isn't the exact one, but this is something comparable to what you'll see. The solid state relays, I do recommend not only getting the relays, but also getting the bases. I don't know what it is about the little bit of vibration that happens, but make sure
I
that
break them every time I take them off.
Do you really?
Yeah, they break like half the time you take them off.
I'm trying to remember because the ones that either are purple or
they're bluish tint.
Yeah, there's some that are blue. There's some that are purple, and then there's the other ones. They make a whole bunch of them, but you just gotta need whatever you're getting. You just need to make sure that they're good for the amperage and stuff. Ooh, there we go.
They're up there with the failure rates of the Cruzette time delays.
Stop it. That's what they look like. But yeah, you have a certain compressor that vibrates really bad.
Stop it.
What'll happen is it shakes the bass around a little bit. All right, I hate you. Okay, now I know I have to edit it. Go ahead, continue.
You did that one, not me.
Oh, I know. That's what I'm saying. I just got to remember that I did it, not you. I'm like, what did he say that I had to take out? Nope, it's something that I did.
Yeah, those things are out there with the Cruzette time delay for failures. Like, you look at that thing wrong, it's done.
Yeah, I agreed with that.
I don't know why they're on the shutdown signals. Like, that seems redundant. You could do that with a CPC sensor or a CPC train or a relay. It's not like that's a relay that cycles a lot. It should never cycle if you have a power outage. So that's one thing to keep in mind when you're looking at that stuff. And then just keeping those valves clean, like once a year, maybe once every 2 years. If it's not a dirty rack, if it's got stainless piping in it, like good luck. You might as well just order an entire pack of rebuild kits or the O-ring kits, because you're going to be cleaning that shit nonstop. Especially if they didn't purge when they did the stainless welding, you're going to have sugar dust all over that thing.
You keep saying sugar dust, and that's what I refer to it as, but I don't remember exactly what it actually like.
It's slag. It's slag. That's all it is.
Okay.
Right. It's just welding slag, but like I've ever always heard everybody call it sugar dust because it's like a fine brown powder. So what?
Nothing.
You're such a degenerate.
I'm not laughing. I definitely wasn't laughing at you. I just hope you know that. I just had a funny thought for a second. Okay, continue.
Yeah, if you had stainless piping, you're going to be doing that a lot. And then, other than that, after you keep them clean and if they're wired right, you shouldn't have any issues besides here and there. And if your head pressure is too low and you're having issues with that, most of the time it's gas cooler control kills more valves than anything.
Gas cooler high. Gas cooler high. So I guess I don't have that. So I have low receiver pressure, where basically if that gets too low. I've also seen where, because if you have a low receiver level, a lot of times this valve will try to open up, or it'll open up to try to maintain that pressure within there to basically raise it up. But I've also seen, what the hell was it? Essentially it was, the HPV was opened up way too far and wouldn't close. And the BGV was just it was during a hot summer day. And this valve was trying to do what it was supposed to do, except for it was forced. It was open, I think probably 75%. There's no really way to know exactly what it was. But because it was giving a high receiver pressure, it was basically opening up the BGV all the way the hell up. And then basically forcing the suction was just ridiculously high.
So if you're low on gas, it hunts like crazy because it starts fighting the gas cooler and it tries to back up liquid into the gas cooler to maintain subcooling. When it's doing that, if you're low on gas, it doesn't have enough liquid to do it. So it ends up backing up more and backing up more and backing up more. Then you get this like terrible hunting. So if you see them hunting all over the place, open, close, slamming all over the place, it may be low on gas, especially if it doesn't have a liquid level in the tank.
Yeah, I mean, it's the only time. This was a weird concept for me to wrap my head around until I really thought about it like you just did. So I was trying to explain this to someone the other day, and I was like, this is the only time where low refrigerant level will essentially cause a high pressure issue. And then that's what I basically explained. I was like, hey, think about it, right? If the unit is running subcritically and trying to maintain subcooling, it's going to try to close down that HPV as much as humanly possible to achieve that subcooling. But it's going to close it down so much that it's going to end up going off on high pressure.
Correct. And here's another issue that this is a common one that we run into is rack's been down for a while, or like you shut the rack down for maintenance and you're going to start it back up. And you're using a sensor that's mounted at the outlet of the gas cooler, which I absolutely hate. I'd rather be inside the rack. So at the outlet of the gas cooler, you have a temp sensor. Say it's on a metal roof or it's on a roof where it's just insulated on the drop. If it's down long enough, that heat is radiating off that roof right through that Armaflex. And that piping and that gas cooler picks it up. That sensor may be so warm from it sitting off, 90, 95 degrees, 100 degrees. It may get so warm from that convection and that radiant heat that when it goes to start, it's going to start that HPV up at 1,400 pound set point. When it does that, when it goes to start, the HPV is not open enough where it could actually have enough flow without banging on compressors, because it's going to start just banging them off on high head instantly because the set point's too high right away to start, and it just murders the compressors. And it won't restart until you get flow going through the gas cooler to cool down, refrigerant flow going through the gas cooler to cool it down. And it'll drop, but it may bang on and off for a half hour to an hour.
So let me talk about this briefly. So basically the HPV has two different modes. We have a subcritical mode, which when it's running subcritical, it's trying to do subcooling. For example here, if with the outlet of the gas cooler is 75 degrees, it will try to maintain 80 degrees saturated condensing temperature on the CO2 to try to achieve that 5 degrees of subcooling. That's the first thing it's going to do. Some set points are 3, some set points are 5. Now, what Kevin's referring to on a real hot day, essentially what's going to happen is it uses this algorithmic PT chart. It's just a chart that I think they were just throwing arrows at something and we're like, that sounds good. That sounds good. But essentially how this works is when we're running transcritically, it takes that same outlet gas cooler temperature sensor and then says, okay, we're running 93 degrees. I want you to maintain 1,252 PSI. So exactly what he just said, if this thing's just sitting in the sun outside the rack and the sun's beating down on it and it already thinks that it's 104 degrees, it's going to try to maintain the outlet or the inlet of that HPV to be 1,449 pounds. If it keeps trying to do that and keeps kicking on the compressors like instantly, there's a high probability that it'll keep perpetually going off on high pressure.
Yep. It happens a lot. It happens more with the sensors mounted on the outlet of the gas cooler than it does inside the rack, because usually the rack is shaded and a little cooler. I don't care how much Armaflex you put on there. They all do it when they're down long enough. So generally what I'll do is either take duster, flip it over and spray it in there and let it cool down just to get the rack back started, especially if it's been down for a while, and it'll take back off.
Cool. Anything else you want to talk about? Are we going to say that we're going to do part 2 and then just never do it?
Yeah, that's what we do all the time.
All right. So part 2.
Maybe next week we'll do flash gas bypass valves.
We did both. People are going to be asking, where's part 2? Get there. I know. All right, guys. We'll talk to you guys next time. Thanks for listening.